Okay, please complete your homework. Even though it's late, you can still get half credit for the missing parts. So you can still finish them, and it's good for the exam. I mean, most people miss questions because I see, oh, they missed the same question homework. That's why they missed it, because they didn't actually do it, okay? So high homework scores, high exam scores, directly related, okay? Now, today we're starting 6.5, which is factoring again. We're not done factoring things. This time we are gonna factor special trinomials that involve squares. Okay, there are a couple of new rules about those called difference of squares and perfect square trinomials. Extremely important. Alright, there we go. Why don't we first understand what a perfect square is? Perfect squares, numbers in variables, there are two cases. It happens in numbers, it happens in variables. When they are numbers, those numbers can be written as a square of another number. We call those such numbers perfect squares, such as 9 is a perfect square because I can raise it to a power of another whole number 3 with a power 2. Okay? 16 is a perfect square because I can make it equal to square of another number, which is 4. 64 is a perfect square because it's 8 squared. Please know such basic well-known perfect squares by heart. Like when I say what's square root of 144, or what number 1 square becomes 144, everybody should scream, oh, it's 12. 12 squared is 144. Okay? So know up to 225. If you know more, it's better. Okay? For example, 400 is a perfect square or not? 400? Okay, what number 1 squared becomes 400? 20. So 400 is a perfect square. Are there any missing numbers here? No, right? Okay. So 36, 49, 64, 81, 100. I think everybody knows up to 100, but it's better if you know up to 225. 5 more. I think you can do it, but it's okay if you don't. Alright, how about the perfect squares in variables? X squared is a perfect square because it can be written as a square of x. You just need to be able to change things into second power, such as x to the 4th. Most people think, oh, it's not a square. X to the 4th is not a perfect square because I don't see 2 here, it's 4. Wrong. It is a perfect square because I can change that 4 into 2 times 2. Once one of them is inside, the other one is outside. So x to the 4th is a perfect square. More precisely, this is what's going on. X to the 4th is actually x squared times x squared. 2 times 2 is 4, and I can write this is double. Once, twice. Anything doubling can be written as a square. So x squared is actually what x to the 4th is. Same way, x to the 6th can be doubled as x cubed times x cubed. 3 plus 3 is 6, right? So we have x cubed squared. Any even power is actually perfect square. 10 is x to the 5th squared because x to the 5th times x to the 5th, right, is x to the 10th. Right? Double. Same once, twice. Is x to the 36 a perfect square? Is it? 36? Yes, because it is square of what? What? 6? Is this true? No, you multiply this, multiply and becomes 36. 6 times 2 is 12. It's not 6, it is 18. Yeah, this is a common mistake. Most people take square of this number and say 6 squared is 36. Wrong. You're multiplying these two. I know your feeling. You feel like, oh, I have to raise 3 to the square and make 9. No. 3 times 2, 4 times 2, 5 times 2. That way. We multiply. Okay. Here is the rule. Once you notice two perfect squares, this is extremely important, with a minus in between, you can factor them in 2 seconds. You repeat A, B, A, B, A, B twice, one with a plus, one with a minus. Okay, I wanna forget about ABs because AB is confusing. I wanna repeat the same thing with a box and a circle. For example, and I need to have squares around them. This is the setup. Once I give you 2 terms in this format, you see a square here, square there, and a minus in between. Oh my god, this is a different square method. This is what you need to pay attention, not ABs. ABs are placeholders. Sometimes it can be XY, sometimes they will turn into numbers. Forget ABs. Do you see something with 2 on the top? Some other thing with a 2 on the top and a minus sign in between? Yep, that's what you're gonna do. Take 2 parentheses, copy that circle and box here. One circle, one circle, one box, one box. And whatever you see inside of these things like X and Y, you put them in here, whatever they are inside those boxes and circles. And what do I put here? Ones with a plus, one with a minus. Plus, minus. Oh, can I put first minus then plus? Contrary to what it says here, can I put first plus then minus? Can I? Yes. Yes, you can. You can flip this order if you wish. You're free to do that. Make sense? Ready for your first question? How would you factor r squared minus 25? Immediately search for what? I don't care what you have here. Put a box and circle. See if you have squares around them and a minus in between. My immediate reaction is, this question is not convenient for this. I quit. Because it doesn't look like we have squares around this, right? It doesn't look like so. Do you see a square here? Do you? This is your circle. This is your box. Yeah, box has a square. Box with a square here. But do you have a square in the second one? Although initially you're not presented with a square here, you can make 25 into square. That's why I gave you this table. These questions, these numbers do not look like squares, but they can be put into square format. 25 is one of them. I can make 25 into 5 squared. So you actually have here r squared minus 5 squared. Do not quit. Just employ this identity. It says take 2 parentheses, put plus and minus, and repeat. It's just copying. It's a kindergarten job. Copy whatever you see in the box into these 2 spots. Whatever you see in the circle into these 2 spots. So it is r plus 5, r minus 5. That's it. Now when I'm doing it, it makes sense. You feel like, oh, this is so easy. But in the exam pressure, I see here 25s. people put 25s here because they see 25. No, we do not put 25. Instead, we put 5. First step is always, this is essential. This is a prep step. You need to convert things into squares first. Change them into squares. Those 3 setups is important. I need to see two powers and a minus between r and 5, around r and 5. Got it? So if it's factoring, we call it, it's not prime, it's factorable. Not prime means it's factorable. We actually split it into 2 pieces. Can I put the -1 first and then +1 next? Yeah, absolutely. You don't have to choose the +1 first. You can go with the minus first, as I did. Okay? Look, these are really 5-second questions. In 5 seconds, you can get either the full credit or 0 credit, because if you mess this up, you won't have a chance. I mean, it's just so easy. There isn't any hard algebra here. Okay, let's go do the second one. Let's clean this up a little bit. Oh, this is good. I set up my box and a circle, and I will put whatever I see around them into whatever I see inside these 2 objects. I will put into these parentheses. Here is what I see. I see 9q, and I see, what is this number? 16, but I need to make it a square here. What? 4. Perfect. So I put box 9q into both spots, 9q, and then put 1 plus 1 minus, put this number 4 and 4. Am I right? What do you say? How can I make sure my answer is right though? How do I know this is right? I didn't check it in the previous one, r plus 5, r minus 5. Well, how could you make sure? What?
It's wrong, but you do FOIL, don't you?
Yes, we do FOIL. Do FOIL, for example, this one. First, outside, inside, L last. What is first terms? R squared. Outside, r times -5, -5r. Inside, 5 times r, 5r. 5 and last, +5 and -5 makes -25. Oh, this was wrong either, right? No, 5r and -5r are opposite. They do cancel, and I verify that I'm right. This is the right factorization. When you do the same thing here, in the first step, multiplying first terms, I immediately notice that my solution is incorrect. Because 9q makes, 9q times 9q makes 81q squared. Oh my god, it's not 9q squared. Where is my mistake? It's not this thing, it's 81. I don't even have to compute the rest, because this is not fitting to this. Where is my mistake?
Q. Just 9q times q.
Right. I should have. Look. This 9 is not under the square. To be able to split these squares into 2 groups like this, everything here should be under this square. This 9 wasn't under that square in the first place. How come I could put this whole thing under the same square? I don't have right to do that. It wasn't under a square. So to bring 9 under a square, 9 should pay a price. What is that price? It comes under that square with a change, with a fee. It turns into, when you put that 9 and q both under a square, q is q, because it's q squared when you square it. 9 turns into what? 3. Okay? So again, when do I do this? Watch closely what square covers. Question is not this. There is no parentheses and then a square. If the question was like this, I was right. Okay? I was right. I could have done this. But my first mistake is again, 9 is out of the square. I put it under a square by choosing a 3q. Now 3q times 3q is 9. That was the first mistake. There is more mistakes here. So you think our problem solved now because it's 3q. You see here, this box is 3q. I need to choose 3q and 3q here. Let's try. Let's try. You will get disappointed again because first terms is 3q times 3q is 3 times 3 is 9. Q times q is 9q squared. 9q squared minus 12q positive 12q because 4 times 3 is 12q. 4 times 3 is 12q plus times 4 times minus 4 is minus 16. Oh, it looks like we got it right, right? Is this the question we are supposed to get? Is it? Take a deep look at.
Don't two minus signs cancel each other out?
Which minus signs?
Oh, sorry. Never mind.
This is plus and minus.
12, why that would
Yeah, it is minus we got here. Well, we're given plus. Oh my God. We didn't get the right answer. This is wrong either. If you try that, I can try it if you want. If you don't trust me, I can try it, and you can see it with your own eyes. Oh, I can't, because when I do this, you will understand what's wrong. Okay, I can't try it on the computer because it has 2 parts. First part needs to be answered first. But what is wrong here is, what is wrong? This rule of separation, this rule here, you can separate this up, is correct if you have 3 things met. These 2 should be square. What is the third condition? It has to be a minus in between, then you can do this. There are 3 requirements. 2 squares and a minus between. Do you have both 2 met here? I have 2 squares, but what do I have in between? I kinda made mistake here. What is this? It's a plus. So you can't do this. Then what is the answer then? No solution. If there are 2 squares and a plus, 2 squares and plus in the middle, when you see such a case, answer is easy. No solution, no factoring, means we call it a prime polynomial. This binomial is prime, so you shouldn't be choosing is not. It is prime. You go to the next question. Okay, so some questions are cheating, kind of tricky. Okay, all right, our next one is, first take a look and tell me, is this prime or not? This is not prime because I see 2 squares and a minus in between. I know I'm going to split this into 2 parentheses. Perfect, let's do it. First, describe me what's coming inside the box with a square and a circle with a square. Yes. What's under the box? You're gonna multiply this twice by itself. It's gonna make 4y squared. What is the number here? 2y comes to this box. So that 2y times 2y makes 4y squared when you double it. Got it? How about the circle? 125 is a perfect number. If you need to cheat here. What is that number? It's 11 squared. That's it. Oh, this question is different. For the first time, the ending number is not just a number. It has a variable part as well with a z square. I don't care. If I see z, I put a z there then. Okay? So how do we distribute these now? What's the rule? Box, box, circle, circle with a plus and minus in between. That's it. Whatever you see inside the box, put it here. Whatever you see inside the circle, put it there. And type it in. That's it. Make sense? For now, right? Until you try this on your own with your own hands, you will see mistakes happening. It's okay to do that. Yep, this is what I'm gonna type in, yeah. First, I'm gonna say it's not prime because I have two factors. You need to put two parentheses here. One with 2y minus 11z. Or why don't we make the first one positive? Let's do positive this time. And then 2y minus 11z. There you go. Okay. Alright, and the last question. Looks simple, but something is different. What is different? If you're noticing something different, you're good. Do you see something different? Tell me what's that? It's just variables, yeah, no numbers. Other than that, there is something, yeah. This one is not square anymore. It's the fourth power. Well, what shall we do now? Again, our setup is this. You need to turn things, no matter what I'm given, I'm going to turn it into one box with a square, one circle with a square, and a minus in between. Tell me what goes into first box.
Z.
Just z.
Minus 1 squared.
The second one is not just y. You're right. It's not just y, because this reads as y squared. This is y to the fourth. I need to convert y to the fourth into square of something. And we have seen that y to the fourth or x to the fourth is x squared with a square. So always take half the power. This is squared with a square. And distribute this into two parentheses. One with the boxes and circles only with base values, no powers. The second one, again, same values with a minus in between. Make sense? Does it make sense?
So you just leave it like that? You want to?
No. Alright. Good question, actually. Always answer the, can I break things further down? For example, can you break this further? Because it looks like this is a square. This is z only. I wish this was also square. Then you could break this into two more parentheses if this was a square. Because you have a box squared, circle squared. You can put this into box plus circle, box minus circle again. But z doesn't have a square, so we are stuck. This doesn't factor anyways because it's plus. Pluses won't factor, but minus, if this would be a square, I could have break it. But now without a square, I cannot. Okay? I need at least a square on each to break it more. Okay. Coming up next is it's something I already mentioned earlier. If you see a plus between two squares, such as this case, I already mentioned this guy, plus between two squares, not factorable, we call it prime. Is not factorable, we call it prime. Okay, because of this plus. This is actually 3 squared. It looks like square difference. I wish this was a minus so I could factor it, but with a plus, no. Alright, more rules, but so far we are kind of halfway through. Any questions? Don't underestimate the power of this property. Oh, you will see this a lot in college algebra. We do it all the time. And if you go higher and higher math, this is a widely used factoring skill. Now, what is next? We will observe more and more relations. First one is, if you have a square between sum of two items like a box and a circle, A and B, let's work with A and B, it's much better here. You actually compute this by foiling, right? It's FOIL, first, outside, inside, and last terms. But once somebody go through this foiling procedure, first term is this, last term is this, but what happened to O and I? Where is O and I? I don't see two separate ones, I see a single term here. What happened? Where is O and I in FOIL? What is O? Outside terms is A times B, AB. What is inside terms? B times A is AB. Oh my god, they are the same. So they actually added them up. There are two same items. So O and I combine into plus 2 twice whatever A and B is. For the case when you have a minus, and when you still FOIL this, you get minus 2AB. Alright, very important thing. We need to stop and think here. Most people confuse these. A minus, and they understand A minus B is they pass this square to each, and they think it's A squared and B squared, these two are equal, and they split this as A plus B, A minus B. This part is correct, yes. If you have a difference of squares, that's how we recently factored it. Question is this correct? Can I pass a square inside like this? A square and B square? Wrong. We cannot. How can I square A minus B then? You need to double it and FOIL it. FOIL it. First, outside, inside, last. Okay? So this is incorrect. Don't they? Or some people say even this. Or they square this, A square, and they say, oh, negative is gonna make this positive, and they say A square plus B square is the answer. Wrong. Again, A minus B squared is not A squared and B squared only. There is a third middle term. Yeah, it's A and B squared on the ends. The middle is this. Where is my mistake? If this is a minus, this is a, oops. This is a minus as well. Okay? If it's a plus, you start with square first, square last. What do I put in the middle? This is a plus. I put plus 2AB. Okay? So, anyhow, it's here, all here. All you need to know is this guy. If you have A square, B square, but a plus in the middle, you make A and B with a plus in between, squared. But if it is a minus, same, almost identical. The only difference is minus. You put a minus between a and b and squared. We're kind of doing things backwards. This will be given to you in the questions, and this will be asked. You will change this to this. And here are the steps again. You need to first determine the first and third terms are square and positives in front. So step 1 is check whether these are squares. Otherwise quit. You have to do something else. And make sure they are both positives. So let's do step 1 first. Do you see positives on the end terms? Yes. Are they squares? No. This is a square, but this is not. So can we quit and try something else? Shall we quit and try something else here?
Square 5.
Yeah. Although it doesn't look like a square, check whether you can make it a square with a simple flip or chart. Use the chart. 25 is a perfect square. It can be made into a square. So it passes the first step. Pass. We check whether the start and end values are positive squares. Yes, they are. Then what is the second test? Second test, step 2, is to check middle term. Is this term twice the product of end terms? Start and end terms. What are start and end terms? The terms without the squares we consider. 5 and y, multiply them. Its product of them is 5y, and take twice of them. Is the middle twice 5y? Is really 10y equals 2 times 5y? Yes, with a minor difference. This guy has a minus. It's okay. We just need to match this part, digits and the variable. I don't care about the sign. Sign is either the same or opposite. Either way is fine. Just check digits, 10 and y. Is 10y the product of the end terms and twice? Yes. 5 times 2y is 10y, is the middle term. Then we are almost done. You just need to make it a perfect square with those two end terms, y and 5. With this middle term, middle sign, you get to choose this according to the sign here. Just inherit the sign there and put it here. Okay? Alright. I'm gonna do this again for those who are lost. I'm restarting. This is the good time to ask a question. Step 1. Check and see if you can make the first and last terms into positive squares. First term is already positive square. Last term is not a positive square yet. I first turn it into positive square. So step 1, check. What do I do with the middle term? Don't touch it. Step 2. Take that black numbers on the end without the squares. Don't ignore the squares, just take the base values, y and 5. And immediately on the spot, multiply them. What is y times 5? 5y. And quickly, right under it, twice it. twice. What is 5y times twice? 10y. Twice means put a 2 in front and multiply. 10y. And then compare the result with the middle term. Is it a match or not? It may not match sometimes. Is it a match? Is it? Is it a match? Except the sign. Forget the sign. Without the sign, is it a match? Yes. Then you can pack these three terms under a square with those two numbers selected, y and 5. How about the sign? You keep this middle sign here. Got it?
So,
Yeah.
if it was 2y squared minus 10y plus 25, and you changed it 5 squared, would you just take 2y squared times 5 squared to get your twice the middle number?
Yes, that's good. But with, yeah, you mean this, right? 2y squared and then
Minus 10y,
minus 10y, and you said this is 25
or plus 5 squared.
plus 5 squared. Then here's the test I'm gonna do. Are these two positive squares? Yes. I quickly multiply them. 2y times 5 is, what is it? 10y. And then I twice it. What is twice 10y? 20y. Is this a match now? Digits and variable, do they match? No match. So this is not a perfect factorization. I can't factor it. Can't factor. I need to try something else, like trial error method or grouping method. Back to that 6.4 long procedure guessing pairs. You have to do that. You don't have a choice. Okay? Alright? And it may not even still factor. This test is to determine if I can quickly pack this into a square or not. If not, you need to try something else. Okay? So this one was good. This is what I'm going to enter here. It's not prime, I can factor it. Alright, I'm not sure which way it likes the answer though. I'm going to try square first. What is the other option? It's y minus 5. How do you make square? It's shift 6, or you can choose this button here. Make square. I think it's gonna like this one. The other option is you can write this y minus 5 square as, this is also correct. If you put this answer down into answer box, y minus 5, y minus 5. I like this one too. You can separate this into two pieces, okay? Isn't square means double whatever you have under it, right? So I doubled it. We're good. Alright, we continue. Any questions so far? Are we too fast? Let me know, okay? We are using same thing over and over. I just copied this. This is not new. When you have three items, first and last terms are square, and the middle term meet the requirement that twice first and second term, and we can pack it. First, you need to prep the question. Always prep the question. Is this a perfect square, positive square of a number? If so, write it down in parentheses. What is this? 25y squared. It's square of what? 5 and y together. 5y. Not just y, not just 5, 5y together. The middle number, we don't touch the middle number. I will keep it in the middle, no change. The last number should be prepped. You need to change this into 6 squared. Perfect. This is your A, this is your B. A is 5y, B is 6. What is the test? Test is immediately underneath it. Multiply this. Multiply. What is 5 times y? 5y times 6? 30y. Then are we done? Are we gonna match this? First twice it, which is 60y. Then we compare the digits only, not the sign. I forget about the sign. Just compare the digits and the variable. Is it a match? Is it a match? Yes, no question about it. 60y, 65, 60y, yes. Matches. So we can pack this. Pack into a square of 25y squared, y, and 36. And it's a plus because the middle sign is a plus. Am I right? Am I right?
No.
I'm wrong. What did I do wrong?
B5y plus 6, wasn't it?
Yeah, you need to move it here. What? These things under the square, not the original stuff. Wrong. This is done all the time in the exam. You get carried over and move the things, original things, but no. The stuff you made it into square, 5y and 6 moves in here. Okay? At this time, I'm going to write it separately. Let's see if it's gonna like it. So it's not a prime as usual. And I will type it 2 separate parentheses this time. One with 5y plus 6. One with again 5y plus 6. It liked it. Okay, you can put it into square. You can put it separately. It's your choice. Three more left. I think we can do it quickly. There is no more trick. Oh, there is a trick here. Sorry, there is one. What is new this time? Almost identical questions. 60x, 60y instead of y, I have xy, and instead of 36, I have 25y squared. So what should I do here? Middle term, we don't touch the middle term. It waits. We prep the last and first terms first. How do I prep the first one? It's 6x. You take square root of 36 and x squared is x. 25, turn it into some number squared. It is 5y. Alright, test. Multiply these two. Multiply 6x and 5y, which is 30xy, because 6 times 5 is 30. And twice it. And check if you have a match. Do we have a match? Do we? Yeah, we do. So we just can pack this up. 6y, 5y. No, not 6, 5y. The first one is 6x. Okay? This is what you need to type in. I'm not typing in. I don't want to waste time. We have limited time left. 8 is trickier. This. What is wrong with this question? 8. It's not in the same order given earlier. We need to start with a square on the first term and a square on the last term, and the middle term has no square. This term starts with a number. So I'm going to first reorder the terms here as p squared first, minus 14p next, and 49 last. This is now in the right order. And this is now so easy. It's just p squared and 7 squared, and the middle term is minus 14 p. I just need to multiply these two. P times 7 is 7p, and twice it, 14p. Do we have a match? 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 Yes, it's a match. So we go ahead and say p and 7 squared, oh, with a plus always, right? With a plus, correct? Am I right? What's wrong? Yeah, because the sign here is a minus. It's wrong, it has to be minus. And the last one. It's okay. I need help with this one. Support the question. Yeah. Our regular routine way is not gonna work. We try to make this a square. We try to make that a square, but is there a number once you square makes 12? Is 12 in this list? Where's 12? Is 12 in this? Is 12 a perfect square? No, there is no number once squared it makes 12. I wish it was 9 or 16. I know what to do with 9 and 16, but not 12. So I know there is something unorthodox with this question. 12 is not factorable. I can't factor t as I can do t here, but there is no number here. What number once squared becomes 3? No number, no whole number actually. I know if I can take root 3 it works, but no whole number, once you square it, it becomes 3. So there is something completely weird here. That thing is, what is our always first step in factoring? You need to look for, before you start anything else, you need to look for something common in all those 3 terms. Alright. Computer is having a hard time processing my erasing, but what is common between 3t squared 12t plus 12? 3. So you need to take that 3 out first. So I take 3 out. I can't, but what's left, I'm spelling out what's left. When I factor 3 from this entire group, it is t squared 4t plus 4. Now that 4 is a complete square. We will continue this next time. I don't have time to fix it, but we need to factor 3, then do what's necessary to the remaining terms, which is tomorrow.